We start with a blank canvas. This is the origin of the canvas. We're looking straight down from the top. Z plus is toward the camera, Z minus is away. By injecting what is the lowest common triangle in an icosahedron with its origin at the icosahedral cap top, we can see the lowest common triangle here by rotating it thusly. You see the 0, 0 origin here. Lowest common triangle. We can add the skin of a 12 frequency BuckyBall, but only this cap piece, not the entire sphere. Just a few elements inside and around the edges of this lowest common triangle. These are the skin pieces. By rotating them, you can see that I've made them slightly transparent so we can see through them. And they do have thickness. So if we zoom in on a strategic spot here, you see they have thickness. And zoom back out. Look at it from the top again. If we look at it from the right side, in other words, move around this direction and look at it from this way. If we zoom out a little bit, this is the origin, this is X minus X plus, Z plus this way. You see the lowest common triangle here across this way. So let's imagine a dome that's 90 meters across. These panels will be quite large, probably 3 or 4 meters across. I'll rotate around so we see the inside of the cap. You see the origin here. This is the 0, 0 origin. By adding 6 groups of struts, we can achieve omnidirectional support of these skin pieces. But we can alternatively, instead of using struts, we can use sheet metal. By combining the sheet metal and using seam welding, you can weld the sheet metal. What I mean by sheet metal, they may be as thick as an inch, depending on the strength needed. Okay, by adding the struts thusly, you see how the center, we go from center across to center, every other one, center to center across, center to center across, every other one, from here to here, here to here. Now there are 3 groups of these. It will produce a grid. Now I'm not going from here across because this one is not here. But it gives you an idea of the grid from center to center, every other one. Now each of these parallel panels or edges of the panels is directly above these struts. The other 6 struts combine adjacent panels. 1, 2, 3. Now we have 2 different kinds of strengthening grids where adjacent panels are connected across the edges, and panels, every other panel is connected across the adjacent edge. So you can see that the center of this panel is connected to the center of this panel. Let me thicken these so you can see them better. Okay. I'll select all of them so that they're exaggerated. Okay, these are all 6 together. First we have the first 3 groups. Okay, the first group goes straight from every other one, like this. From center to this center. If we turn these off, if we deselect these and select the others, you see how they go across these edges, perpendicular to the adjacent edges, whereas this matrix goes across these diamond shapes in parallel with these edges here. So by deselecting these, we select those. Gives you an idea. By selecting all of them, you see how the truss is extremely high frequency. This is the outside, that's the inside. Additional strength can be added by extending, for instance, making a tetrahedron from the base of this triangle and extending it out. Another layer of trusses can be added if strength is more strength is needed. But the basic geometry is here for a least common triangle, or least common triangle. By looking at the outside from above, this is the Z looking straight down on the Z axis here towards 0, 0, 0, 0. The truss is very high frequency, but it's completely inside. If I turn it off completely, where all we see is the skin. This is what is seen outside. I'll look at it from ground level. This would be ground level. If you're only interested in the cap, this is the pentagon of the least common triangle. It goes from here to here. So your base would appear across this plane. Now, if we take a few members of the top of the cap, just a few of these skin pieces, and we add the grid. But instead of adding the grid, we make sheet metal pieces that combine flush with the centers of each skin piece and its surface, like that. Look at it very carefully from above, or from below, I mean. Notice instead of struts going from one point to the other, you have a piece of sheet metal that is flush with the skin and goes from center to center. So by using conventional sheet metal fabrication techniques, you can make these boxes. This is a triangular box here, and here, and here, and here. You can cover that. You can then cover this with additional sheet metal to create a completely enclosed box, which will add tremendous strength. Now, I've made a detail of a cap tip here with a completely enclosed box. If we look at it interactively, yes, we're looking at it from the top. So if I spin it around, now we're looking at it from the bottom. You notice the detail of the sheet metal pieces, how they combine to make three-way grids that can strengthen each other. This one is covered with a piece of sheet metal to make an enclosure here. So by enclosing this space, as seen from the outside, you see that this triangle is completely enclosed, and these pieces of sheet metal are inside to add strength. And the same way can be done here with this. So by breaking this out, you can see the pieces of sheet metal here can be formed to form a double layer dome. See the section of sheet metal here? This one is covered. And we're not limited to this thin cross section. It can be expanded. We can bring these trusses out into pyramidal shapes that can further strengthen the skin, especially if these pieces are thick enough and join effectively with these seams. This can all be done with sheet metal seam welding in a shop before off-site, without any assembly or work done on-site, and be erected with conventional cranes. If, on the other hand, you don't want to use sheet metal fabrication, you want to use some kind of composite material for the skin and use struts to hold it together. These can be your flattened end aluminum tubes with a hole punched. So you can mass produce these in some kind of manufacturing facility, ship them to the site, and use cranes and scaffolding to assemble the pieces from ground level or from the attachment ring. But as you can see, there is a cross section that the skin is you notice the struts go from center to center. Let's say we need additional strength and we want to expand this truss. We can build from the centers of each of these, come out with a tetrahedral truss. So we can expand all of these from here, here, and here out, and then join the tetrahedron, the inner space, and an inner skin can be attached to that. I haven't included that detail, but it can be added to this design very easily. An additional truss can be added in this direction.